Okay guys, as you can tell, I'm not in the classroom today. I am on campus, and I will try to kind of pop in periodically before or towards the end of classes. I'm in a training, so you can post me a question on Emoto, and when I get breaks or have time, I can address that. But sorry for all that. I need you to add the following notes to your interactive notebook, your spiral notebook. I believe we're like on page 18 or 19. We need to have like a blank page before we start the notes. That's going to be our table of contents, excuse me. And I'll give you tabs. So we're going to create a new tab to show our new unit. We're going to get into similar polygons or similar figures and similar triangles. We're going to prove them. And so we're going to I think some of you probably are already familiar with this. We're just kind of tap on some previous knowledge and make sure we know it to the expectation that you're going to have to apply it for 9.3 and 9.4. But for 9.1, 9.2, similar polygons, you need to know the definition. We talked about this with dilation. Same shape, but not necessarily the same size. I put things in different colors to kind of emphasize the key information, so you can personalize your notes. I'm going to start giving credit for that for this unit. Highlight, color code, whatever you want to do, but you need to have the definition for similar figures, and you need to have the properties to prove similar polygons. So, and in order to be a similar polygon, the two things that must occur is that if you have corresponding angles are congruent first, you have to check that, and then corresponding sides are proportional. Really, and you can pause the video if you need to, rewind if you have to. Really, similar figures have to show some type of proportional relationship. And on our dilations, we saw things were proportional if the image and the pre-image, the line that we drew through them, we saw collinear lines, collinear points that all intersect at one point. So they have to have the same scale factor for that to occur, for the enlargement or the reduction to be, and the way that we know this, there's three ways we can do that. We have to see equal ratios, same cross products, or the same multiple. So it's the same thing on this next little slide, but we're going to use this trapezoid to show that relationship. So make sure you copy down this trapezoid into your notes. Also label the pre-image, the image, and the units to represent the side. And what we're going to do is we're going to compare corresponding sides. And to help you to understand that, one, you need to have your figure go in the same orientation. And this trapezoid is doing that. Corresponding sides are going to be pretty much in the same position, same orientation. So I'm going to highlight these. So if I'm starting with, let's say I'm looking at this the top, the base of the trapezoid, the top base. Well, the top base of the other trapezoid is this. So the 4 correlates with the 3. Then if I look at the height of the trapezoid, that's the distance between the bases. That would be the 5, and that correlates with the 3.75. If I look at the second base, because the trapezoid has 2 bases, we have 8, which correlates with the 6. And then the other side of the trapezoid, the slanted side if you want to call it that, the 7 correlates with the 5.2. So I'm kind of color coding so you know which parts I'm going to show the relationship with. And so for our equal ratios, I'm going to scroll this up just a little bit so you can see at the bottom, because I'm going to put 1 and 2 together so you can see them all at once. All right, so if I'm talking about and I know my color might be a little off, but if I'm talking about equal ratios, I want to compare the corresponding sides, and I want to write them as a ratio. You can do pre-image or image to pre-image. I'm going to do pre-image to image. If I'm doing the scale factor, just make sure you go in the different order. But basically, I have 4. That 4 that we have up there went with 3. And that was equal to another corresponding side would be, and I'll change that to blue because the highlighted was blue, was the 5, which correspond with the 3.75. And then my other base, which put in green, we have the 8, which correspond with the 6. And then our last side, which I'm not going to do in yellow because you're probably not going to be able to see that, we had the 7, which correspond with the 5.25. But we're going to put a yellow box around that to know that that was the yellow. I can go ahead and just highlight all these. Make sure we know what we're doing. This was my green base, and then my height, and then we had the other base. Okay? Alright, so one way to determine if something is proportional, we have to look to see if we have equal ratios. And so we just want to simplify each ratio. 2 ways to check to see if we have the same ratio. Simplify as a fraction. Okay? I'm going to show you on the calculator 2 ways to do that. One way is to just look at the comparison between the numbers. That would be just convert to decimal. And then I'll show you how, if you get a decimal answer, how to convert it to the fraction as well. So I'm going to show both as soon as this calculator gets loaded. And so the ratio we have first is 4 to 3. And when you put that in the calculator, you can use your division bar or you can use the fraction key to enter it. Both of those will be able to simplify, especially if you're going to do it as either one. So if I do, just so we know, add a graph, if I do 4 divided by 3, that answer is my simplified ratio, my simplified fraction, 4 over 3. Even if I do control divide to get the fraction bar, and I put a fraction, or type in a fraction, oops, did I put it in there? I can't tell. All right, there it is. It's the same answer, 4 divided by 3. And then, of course, if I do control enter, it'll convert it. Oh, control enter. Is it letting me control enter? Yeah, it'll convert it to a decimal. Okay, so I'm going to write this fraction as the decimal because we have decimals in our other ratios. And then I'm going to show you how you can convert it back to a fraction, just in case you're not too sure. So what we had was 1.3 repeating. All right, so this ratio simplified to 1.3 repeating. And then if I do the remaining 2, so I'm going to go ahead and just make sure you can see. If I do 5 divided by our 3.75 and check, get the same decimal. Now that's still saying that you can convert that to a fraction if I want to check the fraction. If you hit menu and then go to my numbers, it says approximate to a fraction, that's number 2, and just hit enter, we see that that is actually 4/3. So we get the same, we're getting the same ratio. We got to check all of them. So I had also 7 and 5/25, or 2500. So, okay. And then we had 8/6, which we also know is 4/3. All right. So we see that they all come out to be the same. And that's what you have to check. So I'm going to show the decimal, and I'm going to show the actual simplified fraction. So this is 1 point, which is the same as 4/3. So this was 4/3 for all. If they have the same ratio, simplified ratio, then it's proportional. Okay. Now the other way you can do it is check the cross products. All right. So in checking the cross products, you just cross multiply, and we're going to talk about parts of proportions. But I know you're familiar with this. But basically, we're just going to go 3 times 5. I'm just going to write it above. So that would be 15. And then when I do 4 times 3.75, that is also 15. Well, I'm going to check that for all. So try that right now, see if you get the same number, because you have to have the same cross products in order for it to be proportional. So I'm going to let you do that. Alright, so if you check the cross products, they're not all the same number, the same product, but when you cross multiply, the top and the bottom of the 2 cross products are the same. So if you notice, we should have 26.25, 26.25. Those were the same when I cross multiply the 5 and 3.75 and the 8.6 and then 42 and 42. So they all have the same cross product. So that's another way you can check to see if it is proportional. So looking at the equal ratios and looking at cross products. Sometimes people just write the proportion and then they can see physically just looking at the cross products that they're the same, and then they move on. Okay, so just make sure you check using either one. The other way would be looking for a same multiple. Now, to get your multiple, you normally do, or you basically use your scale factor. Okay, And we know that the scale factor basically is your image over the pre-image. I'm going to abbreviate that. Or you can look at it as your new over the original. Alright, so what I want to do is I want to do this comparison of just two corresponding sides and find the scale factor between them. So let's say I just do the bases, the first base, the 4 and the 3. Well, because it's image to pre-image, then the scale factor would be 3 over 4, okay, or my multiple. So this is what I'm multiplying each side by, and to check to see that I get the new length. So what I do is I start and I just compare with each one. So I'm going to go with my 4. If I had the length 4 and then I multiply it by the 3/4, it equals 3. So that worked. Okay, and then I just check to make sure it works for all. So then I do the same thing with my 5. 5 times 3/4, that gives me 3.75. So it works on that one. Let me extend this page. Alright, and then we're going to do that for, we have the 8, or we have the 7. Well, we have got 8. 8 times 3/4, that equals 6, so that worked. And then we have 7 times 3/4. That was 5.25. That worked as well. So if it works for all, you can physically see multiplying by that scale factor gives you the new image length. Then you can use that to also prove proportional, proving that it's the same multiple, same scale factor for every side. So you just pick which one you want to use. All right. Then we want to make sure you understand how to use a proportion to find the missing side, because that's what you're going to use to find the missing side. Let me minimize that. So what I haven't read is important. It tells you what to do. This is what you need to remember. This is basically what we're going to apply with this unit. Now the blue, a proportion, basically what it is just an equal ratios. It's a statement of equality between two ratios. We usually just use 2, but just make sure they have to be equal ratios, okay, to be proportional. And the example they have here is A over B is equal to C over D. There's parts of a proportion that I want you to kind of get used to, because you're going to see this in the context of a problem. So we have parts of the proportion. We have the means and the extremes. Now, most of you think of the mean as the average. And what they did is they rewrote the proportion instead of as a fraction, because you can use also semicolons to show a ratio. And because the proportion are 2 equal ratios, they just rewrote the 8 over B is equal to C over D using semicolons. So 8 semicolon B is equal to C semicolon D. So if you see right here, the means are the parts that are in the middle. I'm hoping you kind of recognize that. And the extremes are the parts on the outside. Kind of extremes, the outliers at the end, to the extremes. So just understand those parts, because they make reference to them in problems. Another way I look at it is the means, and I don't know, I just see when you cross multiply. If I'm going from the bottom to the top and I'm multiplying, that's my mean. And if I go to the top to the bottom, that's always my extreme. So that's another way of seeing those parts. So just know the vocabulary, recognize where they be located in a proportion. All right, so there are additional properties that go with proportions as well. So one of the things is that setting up a proportion, you don't have to do it one way every time. You just have to keep the same relationship to keep the proportional relationship. So you can have, you can write a proportion in many different ways. One of the ones is that if the original proportion I gave was A over B is equal to C over D. It's going to be equivalent. I can rewrite this proportion as long as I keep the pattern the same. So if you look at what I have down here, is I have A over C. So basically I'm comparing the top parts to the bottom. So I'm just going to rewrite that. So A over C is going to be the same as B over D. I'm hoping you see that. Now, if I keep, if I add something to a proportion, remember I said you got to keep the pattern the same. So I'm hoping you recognize what's happening here. If I did a plus b over b, so basically I'm adding the denominator, the bottom part. And I have to do that same thing to the other ratio. So this would be c plus d over d. And I'm going to check, the first thing we're going to add into your notes is some guided practice, is to check to see that you understand these relationships and what different proportions. So these 6 problems I want you to kind of complete and do. I'm going to kind of explain and get you started, and then I want you to kind of finish and then check your answer. So this first one I'm hoping you see is pretty simple. It's kind of going with the last one I just showed you with a plus b over b equals c plus d over d. So you have a conditional statement. It says if x over 2 is equal to y over 3, then they're basically doing an addition. So this should just be over 3. Okay, because they just added 3. And also remember, because the proportion is like a fraction, we have to still keep our fraction rules when adding and subtracting. You have to have a common denominator. So that's what they're trying to show there. When they're adding the 2, that 2 was the denominator. So that's why they're able to do that addition. All right, on number 2, we got a over b equals c over 3. Then a minus b equals 4. We got to think about how did they get that 4. Well, back to what I was saying about using subtraction of fractions, using the same rule, common denominator. Really, if I'm subtracting b from the fraction, it has to have a common denominator. So basically, I'm just subtracting b over b. So I can put the top, a minus b at the top. So I'm using that same relationship with my 7 over 3. If I subtract this fraction, I have to have the common denominator, so that's 3 over 3. And 7 minus 3 gives me basically the 4. So we know that the common denominator is 3. So it's 4 over 3. And I think some of you can see that physically, just mentally, and then just do it. So let's try it 3. If a over b equals c over d, then a minus b equals, hopefully this is very similar to what we did with the other property, and hopefully you see it's just c minus d over d. Okay? And then, now we have a little combination here. It says if 5 over 3 equals 9 plus x over x, then 2 over 3 equals, so think about what am I doing to the 5/3 to get to the 2/3. And I'm hoping you see we're subtracting by the denominator. So for this first 5/3, let's subtract by 3 over 3 to get to that 2/3. Okay? So, since I'm subtracting by the denominator, I'm going to do this whole ratio and subtract by the denominator. So that's 9 plus x over x minus x over x. Alright, when we subtract, we're just subtracting the numerator. So if I have 9 plus x and then I subtract an x from it, you'll see how that would end up canceling each other out. That becomes 0. So we see that 2/3 is going to equal to 9 over x. Okay. Alright, try 5 and 6. Pause the video. I'm going to put the answer and the work. I'm going to pause my video as well. So just check it. And if you have any questions, then post it to me on Emoto. Appreciate that. Alright, check your work, your answer. Hopefully you added or subtracted correctly to get to the correct ratio. I put the steps for each one, and if something's still a little confusing and you have a question about it, just kind of this will be a clue or indicator we need to post some questions. And based on my responses that I get, I know what type of problems we need to do extra practice on, okay? You will see something like this on your first quiz, being able to simplify the proportion, also solve a proportion, which we're going to get into. But understanding this helps you with solving correctly. Alright, so our first example, which I need you to draw, and I kind of put your square units onto the example because you have graph paper, so you can just basically map this out. So the first rectangle we have here is a 2 by 1, 2, 3, 4, 5. 2 by 5. And then the second rectangle we have is a 3 by, and this is actually 7.5 because I put 7.5 up there. And understand that this represents our pre-image over here. And this is our image. Now, understand that these are not in the same orientation, and so you have to kind of spatially just visualize it, put it in that orientation, and just recognize which parts are going to go together. So understand that if I'm looking at the 2 actually corresponds with the 3. Okay, those two, and I'm just kind of color coding so you know what parts go together. And then if I'm looking at the 5, okay, those 5 units actually go with the 7.5. And so they want us to determine if the figures are similar or congruent and justify our answer. So if we're going to determine that, we're just going to have to go straight to our ratios, comparing the corresponding sides, and then to see if that ratio is equal or has the same cross product or the same multiple. And then if it's actually the exact same number for both, then we can see that it would be congruent. Now we can see this is physically not congruent because they're not the same dimension. This basically is a 2 by 5, and this is a 3 by 7.5. So they would have to be the same dimensions for it to be congruent. But what we're going to check is to see if it's proportional. So we got the 2/3. Those are the two parts that go together, and that was our purple or pink or however you want to call it, this right here. The 2/3 corresponds with 5 and 7.5. Okay. Alright, so 2 ways I can do this. Look at my simplified ratio or decimal, or look at the cross product. So if I do my cross products, my mean is 15. My extreme is 15. So since they're the same, or I can reduce. This reduces the decimal is 0.6 repeating, and this is also 0.6 repeating. 2/3, or I can say this is 2/3, the simplified ratio or fraction, and it is also 2/3. Alright, since they all equal, that equal, since they all equal, we are proving that it is proportional. Sorry about that. So this is yes, they are proportional. And so they are similar. So they're proportional, they are similar. And then on our next example, says determine if these figures are similar. Alright, so we got our pre-image and our image. Remember, we got to take the parts that are corresponding with one another. So I see that my base, the horizontal line here, this 6, corresponds with the 4.5. So I'm going to set up that ratio, 6 and the 4.5. Check to see if that's equal to the other leg, which was our 5, and sorry for that, and our 3, 5/3. And then I want to check to see if the hypotenuse correspond one another, are proportional. So that would be the 7.8 and the 5.4. And so I like to just look at the cross products. To me, that's the quick way to just get to my answer. So if I do the cross products here, 4 and the, where is it? Yeah, 4, is it 4.5? Yeah, 4.5 and the 5. And then if I do my cross products, the 6 and 3. So this was what, 22.5, and this is 18. Already I see these are not the same. So I automatically know that this is not similar. That's my answer. And the reason why I know that is that it's not proportional. Okay? You can say because not proportional. And the reason why I know that they're not proportional is because I didn't have the same cross products. Alright, so make sure you know the difference when it is similar and not similar. Now, this next little understanding similarity needs you to copy this one down as well. The first thing we have here is what we call the similarity statement. On the first slide that you had, we had this symbol here. That symbol is for similarity. And this reading of this is the same as we did with congruency statements. Order does matter. So understand, this is the first one, first quadrant law, A, B, C, D. So whatever comes first, that will be your pre-image. and this would be the image. And like I said, order matters. So just like before, BC is going to correspond with MN. Okay? So when we're talking about similar figures, the first characteristic that has to hold is that corresponding angles are congruent. So they have already told us that they're similar with the similarity statement. So I just need to match up my corresponding angles. So if I'm at C, C is the third letter, it corresponds with N. So the answer here is C is congruent to angle N. And then I think you can do the rest. Angle M would be congruent to angle D. Or I should do that in a different color. Now they're comparing sides. They're doing a ratio. So they did AB, the first two letters, to LM, the next two. And then they're comparing MN, and I've already talked about that. That would be BC. And then if I do CB, CB we already know corresponds to blank. If I'm going from NM to OL. So they went to the last. This was first and last of OL. So that would have to be first and last on the first, the pre-image. And that's going to be AD or DA. Okay. Now it says, what is the similarity ratio? Your similarity ratio is like the scale factor, but basically we're just going to do the reciprocal of it. It's now just looking at the image to the image. You just go in order from the statement. Since we said A, B, C, D is similar to L, M, and O, I'm going in that same order. And now I just got to find corresponding parts. So I have the measurement of CD. I know CD is the last two, so that is NO. So I find NO. I'm putting the same color so I can see that they correspond together. And I know that that is, I believe, 8. Yeah, 8. Excuse me. 8 over 18. And then we're going to I believe that's an 8. Yeah. Let me find my. Yes. And then we're going to simplify that, which would reduce to 9/4. So I always, simplify it. Ooh, oh man. Oh my goodness. Okay. Gosh. I gotta get that. Sorry. Alright, so our next little thing, determine similarity. So we got 3 more examples. We just got to add to our spiral. If you determine figures are similar, you must make sure the corresponding sides are proportional. So that's in red is important. Okay? And you have to identify the scale factor and write the similarity statement. So, in a problem like this, well, I need you to add something because it's missing in the figure. BC is parallel to DE. Okay? Alright, so for something like this, because you have overlapping triangles, whenever you have overlapping triangles, because we have them, I don't know if you notice, we have a small one and a big one. We kind of talked about this like the very beginning of the school year. Whenever you have something that's overlapping, you will need to redraw them separate. Dang it, I can't write. I'm still tripping off of what I just did just a while ago. Alright, so what I have here is I have my first triangle I have is the whole triangle, which is the ADE. So I'm going to redraw that. It's my large triangle. ADE. I'm going to highlight that. Alright. ADE is going to be compared to the small triangle, which is the ABC. Kind of see the colors kind of overlap there. Alright, so I'm going to redraw my small one. It's not very accurate, but it's just a sketch. And yeah, A, B, C. There we go. Alright, now, first thing I hope you notice is the reason why this is overlapping is because they share this vertex angle, this top angle here, A. symbol for them. Okay. Now, one of the things that we did for the beginning of the school year when we start looking at logic and proofs is that whenever we saw that they had a common angle because it was overlapping and was shared, we would write angle A is congruent to angle A, which was our reflexive property. And the reason why it's reflexive, we know because it was a shared angle. Alright, because if I'm going to prove that these two triangles are similar, I first have to check the angles. And all three corresponding angles have to be congruent. So on this first one, we have the shared angle. And then I'm going to use my prior knowledge with parallel lines. Because BC is parallel to DE, I also know that angle ABC, and I'm going to put two arcs, is congruent to angle ADE. So that means this angle D corresponds or is congruent to angle B. And the reason why I know that is because we have corresponding angles. So angle B is congruent to angle D. Reason, corresponding angles are always congruent. Well, that goes for the other side too. So I'm going to put three arcs. So angle E goes with C. Alright, and you can write that down. But now I showed that all three corresponding angles are congruent. That's the first criteria for similar figures. Then the next thing is I have to show proportional. Corresponding sides are proportional. Well, let me go ahead and just mark the sides that I know. In my small triangle ABC, I know AB is 10 and AC is 10. And right now, I know that this is an isosceles triangle. Because if I have two sides congruent, then that's isosceles. And because it's isosceles, I know something about BC and DE. But let me finish what I have. If I'm looking at A to D, that's 25, I believe. Yeah. And 25. It is also isosceles. Well, if I have two isosceles triangles with all three angles congruent, I need to check the corresponding sides to see if they're proportional. Now, I don't need to do this twice. I just need to do this once because I know two of them are the same. So basically, I want to check, well, I can check with both, but I want to check that we get the same ratio, which I know I'm going to, because if I have basically, 10 to 25, that is going to be the same thing as 10 to 25 because they're the same. And they're actually the same, which if I want to reduce that, I get 2/5. They all go down to the same ratio, same cross products, 50, 250, okay. So I have two sides, and I'm just using some natural reasoning to talk about the third side. Well, if I know the two sides are proportional, I'm talking about an isosceles triangle, then DE is also going to be, or I need going the other way because I started with AB. BC, excuse me, is also going to be proportional to DE. Even though I don't have that measure, it's an isosceles triangle. And if I know the three angles are congruent, and I know the ratios between the two sides are the same, then the distance between DE and BC is going to have to be the same too. So, all corresponding angles are congruent, corresponding sides are proportional. Now I can write a similarity statement. So basically, I say triangle ADE is similar, use that symbol, and then the triangle symbol of ABC. And now we're done. Oh, the scale factor. Because they wanted the scale factor. Well, we got to go from image to pre-image. So here we did, we did an image to pre-image. So the scale factor, K is usually our variable that we use for scale factor is 2/5. Yeah, because it was a reduction. Alright, so we have one more practice. Now, they tell us in this one it is similar with this statement right there. So I'm going to just highlight that. Okay? This is important. We've got to read it and use it and apply it correctly. They want us to find the length of EF. Okay? We had a slide that came after our using proportionality or proving proportional. It was in red. It says when finding a missing side with similar figures, you will need to write a proportion to solve. So we're going to have to set up two equal ratios and then cross multiply to solve them. Now, we can write the ratios with corresponding sides. So I think just by glance, I think some of you are probably going to write 10x minus 5 is to 3x plus 1.8. And I'm going to tell you right now, cross that out and stop right there. That is wrong. Because we have to go based on our similarity statement. If we look at our similarity statement, let's go back to highlighting, show characteristics. Remember I said order matters. So if I'm looking at AB, let me do this on a smaller line. Here's AB. That looks green, but AB. A to B goes to D to E. So here's my AB. That's my 10. It goes to D to E, and that's actually the 6. Okay, this second image is kind of rotating. It's not in the same orientation as our first one. So that goes also for BC. BC corresponds with EF. It goes here. And then we have, or did I do blue already? I did. Then our last one, CA, first and last, corresponds with DF, first and last. So I would highlight this. Did I not highlight this? There we go. I would highlight this so you can see which parts actually really go together, because the similarity statement is important. You have to follow the statement to make sure you get the corresponding parts. So really, if I write my proportion, and I'm going to scroll this up just a little bit, really what I have is I have 10x minus 5 corresponds with the 4x plus 1. And you can say that's equal. We need another pair of corresponding sides. Well, I can do the 8x minus 3 with the 3x plus 1.8. And now I can cross multiply. But we want to work smart, not overwork. Because here I'm going to have a quadratic, because I have two binomials that I'm multiplying. I'm multiplying this 10x minus 5 times, this would be my cross products. So my suggestion to you, because we want to work smart, is that if I ever have a side that I have a value to, my blue side, I want to use that, because that is actually going to give me my scale factor. And it will simplify the amount of work I have to do. So instead of doing 8x minus 3 over 3x plus 8, I can do my 10x minus 5 over 4x plus 1 is to 10 to 6. And then now I have a much simpler cross multiplication algebra problem to do. So when we cross multiply, let me extend my page here. When we cross multiply, basically we get 60x minus 30 equals 40x plus 10. And we're going to solve for x, so subtract, it gives me 20x equals 40, x equals 2. And they want us to find EF, so we're going to go back and plug that in for EF. And EF was the 4x plus 2, plus 1, excuse me, was the EF. We're just going to plug that in. 4 times 2 plus 1. I already know you know that mentally, but I'm just in case, so we know it's 9. So work smart, okay? Do not overwork. Use always sides that you already have measurements to, because that is your scale factor, your similarity ratio that you can use, and then use 2 other sides. All right, so the last one we're going to talk about. I'm sorry about this. I just realized this is kind of lengthy. I'm addressing these type of examples because those are the examples you'll see on an assessment. Ow. In a triangle, the ratio of the measures of the 3 triangle are 2 to 5 to 8. Find the measure of each angle in the triangle. Well, because we're keywords, we want to find the measure of each angle of the triangle. We're talking about 3 angles. Because we're talking about angles of a triangle, hopefully we're using triangle sum theorem, which basically says equals 180. So we know that the angles are not 2 and 5 and 8, because that does not equal 180. But we can use that comparison to find what the scale factor is, see what we're multiplying to each of the angles, so that it has a sum of 180. So instead of doing addition here, I'm going to do addition, but let's change this. So it's 2x plus 5x, because there's some type of scale factor that's happening to each of the angles. Remember, our scale factor is the same multiple for all the ratios and for it to exist, it doesn't affect the ratio. So we have to make sure we have that scale factor. We can find that by taking 2 times a number. So we're just going to combine like terms here. We get 15x equals 180, and then solve for x. X equals 12. They want us to find the measure of each angle. So then I'm going to come over here. I'm going to 2 times 12, and 5 times 12, and 8 times 12, which I hope I don't run out of room. So we have 24, 60, and 96, and it does equal 180. So I have the measure of each angle right there. All right, that is the last one. So, guys, you're going to have pretty much some Emoto quizzes whenever I'm out to check that you are understanding the lesson and we're not missing out on instruction. And so on Emoto, after you complete your notes, there are going to be probably like 7 questions. It's not going to be that long. To kind of correlate with the notes, I'm just going to see, can you give me the answers to some of the examples or some of the proportions that you needed to copy down? And maybe a couple that you can do on your own. See, check for understanding. And if you have any questions, I do need you to post them to me on Emoto. And make sure you had completed your writing assignment. You follow the instructions that I had on the board. I probably should have led into the video with that. And like I said, if you have any questions, hit me up on Emoto. My plan is I'm off. I'm not in the classroom, but I'm still on campus and I'm in a training, and I'm not that far from the room, so I'm going to try to pop my head before and after, or before class, beginning of class, or at the end of class. And this is going to be for Tuesday and Wednesday, so I won't see you until Thursday. So I don't want you to lose out on instruction. I don't want you to think we're going to fall behind. We are going to start off with a unit that you're pretty much familiar with in regards to proportions. I know you did that in middle school. We just kind of remind you. We will be adding some quadratics to it. I'm rambling. Stop the video. Finish your notes. Make sure you understand the material. Do your Emoto quiz. And I will see you on Thursday. Well, I'll see you tomorrow. All right. Thanks. Bye.